Hello everybody, I will start my today's another live coding session. So today I solve this question. Remove duplicate from sorted array. Given an integer array num sorted in non-decreasing order, remove the duplicate in place such that each unique element appears only once. Okay, I have to remove duplicate in place. The relative order of the elements should be kept the same, so still non-decreasing order. Consider the number of unique elements in num to be k. After removing duplicate, return the number of unique elements k. Returns the number of unique. I see. The first k elements of num should contain the unique numbers in sorted order. Yep. So the array should be mutated, and the remaining element beyond index k-1 can be ignored. Okay. So let me clarify my understanding on this question. So as the interface, I'm giving an integer array nums, and I will return the number, which is integer. So this is the number of unique element in the given nums array. And also, as a side effect, so nums element should be mutated. Yeah. Have sorted unique elements. Okay, I see. So it works something like this. So let's say I have, say, like this. In this case, the first, let me change it. So in this case, I have 1, 2, 4 first. So for this part, first 3 elements, they are sorted. And for here, I can include any element. So it doesn't matter what I put here. Maybe 4, 4 is fine. 0, 0 is fine. Anything is fine. And then I will return 3. Because there are 3 elements which are unique. Yeah. Okay, so that's my understanding on this question. So I would think if there is some constraint which matters in this question. Mhm. So this is integer and number can be 0 or negative number, positive number. And I just want to confirm if this nums has at least one element or not. Yep, there is at least one element here in this nums array. Okay. So for example, in this case, I should not return any, no mutation on this array, and I will return 0. Yeah. Okay, so let me think of the approach I can take. So the brute force approach I come up with is just linear scan the, given nums and creates the list of unique numbers, and then updates the first k element in the given array with that another array, then returns the ranks of that another array. So this takes overwhelm time because I do the linear scan, and then I put the element in the created, unique sorted array into the original array. So it takes overwhelm for each. So in total, it should be overwhelm. For space complexity, this should be constant because over n, because I have to create another array which stores the numbers in the sorted array. Yeah. But probably I can optimize this. So instead of creating another array, I use the 2 pointers. So let me demonstrate it here. So I move the writer and reader. So reader tries to find a new element. For example, here, when reader is 1, I find the element 1, which is the first element to see for reader. So I put this number 1 to writer position. Then I move reader and writer. Now 2 is new to reader. So again, I put 2 on the writer position, and then reader and writer should be moved. Now reader says 2, but it already seen because previous read was 2. So I don't do anything on this. Now reader reads 4, which is a new element. New element means that this is different from previous number. So I put this 4 in this writer position, then move reader and writer. Yeah, in this way. So 4 is not new to reader because the previous number was 4. So I move the reader only, and then that is the end. So now I can return the index of writer position. So if writer hasn't moved at all, oh, it doesn't appear in this case. Yeah. But let's say all of the elements are unique, then writer should be at this position, which is exactly the length of the number. So this, yeah, that as expected. Okay. So that being said, I will quickly say I use 2 pointers. And keep track of read, num. Yeah. So this is used this is our num is used for reader to judge if the current number is new or not. Okay. And in the end, I will return writer position. Okay, so with this approach, the time complexity should be O of n because reader and writer moves independently at max n times, assuming that there are n elements in the given array. For space complexity, this should be constant because there isn't any data structure, which is non-constant, I have to build. Okay, so that being said, so I start reader writer 0, and no, and I need this here. Okay, so if this is different from the previous number, I did something here. Otherwise, oh, and anyway, I have to update this. I write it first because so that I don't forget it. So if they're different, I put it in the writer position. Then I move the writer position and also reader position. But anyway, I remove the reader position, so I put it here. So now what happens is that if new number is new, reader number is new, I put it in the writer position and the writer. And anyway, I move the reader position and I update the previous reader num. Good. And I return W in the end. Okay, so let me walk through my code. As I said, something I had to confirm is this case, 1, 2, where all the numbers are different, and also this case when the numbers are the same in some cases. I mean, there's some duplicated numbers. In this case, writer begins from 0 and the reader begins from 0 and first 3 in right and prev num is 0. No, none. So first 3 when reader is here, nums r is 1, nums prev reader num is none, so they're different. So 1 is put here on right position. Then writer is moved by 1. Now in line 64, oh, actually I don't have to move the reader position because reader r is moved by the for loop. So now pre-value num is nums r, which is 1. I'm a bit wondering, I'm moving this pre-value num after updating the nums r with nums. Yeah. When w is equal to r, nums r is already updated. I'm a bit wondering if this is okay. So let me do that later, just in case. So before updating the writer number, I did pre-var num. So yeah, I think this is good. In this way, pre-var num is always the previous, original nums r, even if nums r is updated in line 62. So in this way, r num is 1, so pre-var num is now 1. Yeah, good. Now reader is moved to index 1 and our num is 2. So 2 is different from 1. So nums, this one is updated with 2 and writer is moved and also reader is moved. The prev num is updated with 2. But this is the end of the for loop. So I go to line 67 and return w, which is now 2. Okay, so this is totally as expected. So I passed this test case. Okay, so when 1 to 2, in this case, reader writer begins from 0, 0. I speed up. So here, 1 is put here on the writer position and writer is moved. Then reader comes to index 1 and pre-var num should be num and then 1. Now here, pre-var num is 1, current reader number is 2. They're different, so I put 2 here and move the writer position, and the reader comes to index 2. Now, sorry, and this should be 2. Now pre R num is equal to 2, which is current R number. So I don't update writer position. So here I go to reader moves, and now this is the end of the for loop. So pre-var num is actually updated with 2, but it's fine, and I return index 2. Okay, so this is as expected. So I also passed this test case. Maybe I should have checked another case like 1 2 2 2 2 or something, because in that case, pre-var num should be always the same for this 2 range. So maybe I should check it also, but it's totally fine because I've covered those line. So let me execute. Good. Good, accepted. Okay, so let me quickly wrap up. So today's of the question, remove duplicate from sorted array. In this question, I'm giving a sorted integer array nums, which is non-decreasing, so instructively increasing. And I will remove all the duplicate. So let's say there are k unique number of elements, in the given array. In that case, I mutate the first k elements in the given array and put all the unique numbers in non-decreasing order. And then I return k from this method. Yeah, so basically I use the 2 pointers, reader and writer. So reader traverses the given array nums. Then if reader finds a new element, then it puts the number on the writer position and moves the writer by 1. Yeah, then in then I return the position, index of the W writer because it exactly equal to the number of elements which are new to the reader, which means that this is equal to the number of unique elements. Okay, that being said, I finished my today's coding practice. Thank you so much. Bye.